Good morning, everyone. We are gonna go ahead and get started. Today, we're gonna be talking about getting RAG in production. Hot topic, and I'm really excited to go through it today. If you have any questions throughout this presentation, feel free to throw them in the Q&A, or you can just, if you're on LinkedIn or Twitter, you can just leave a comment and I will answer them, or Maria will be looking at LinkedIn and Twitter. So like I said, today we're going to be talking about getting RAG into production. We're going to go through everything from data to evaluation. I'm going to be really focused on the core components and just really bringing everything together today. We will do more webinars in the future where we're much more hands-on, and I'll be using specific tools to deploy. This one, I am purposely trying to be kind of vendor agnostic and show you all the things to think about and what a production grade LLM system looks like. Okay, so let's start with the stages of LLM development. So if I'm building an LLM system, there's 4 stages. There's data, training, serving, and evaluation. Now, if you're looking at this and maybe a little confused, that's because this is actually my ML stages. But what's interesting, or what I find interesting, is that the LLM stages map almost exactly to these 4 stages. So the first bet, the data, this is all about feature engineering and prompt construction. This is where your embeddings come in. This is where you take your data and put it in a form that is usable by your LLM system. Model experimentation and training becomes fine-tuning. Very similar. You give it, example data, and then you train it. Deployment, again, very similar. Either you deploy yourself or you use an API or a vendor. Now, deployment obviously is very different in that it's a much larger model. You're going to need GPUs, and it's just a very different problem space. And then finally, there's monitoring and evaluation, which is similar to data, very, very similar. There will be a focus on human feedback loops, which is common in certain parts of ML, like recommender systems, but less so in others, like computer vision. So the LLM stages go from feature engineering and prompt construction, fine-tuning, deployment, and the human feedback loop. So let's build up to that. Let's first build up to RAG. What is RAG? So when you use an LLM, like we've all used ChatGPT, this is kind of how it works. Us, the user, we have a question or something that we want to get an output for. We put that into a prompt. So we kind of have our own template. Different people have different tricks. You might say, like, explain it like I'm 5. You might say, be brief. Like, there's a lot of tricks and things that we learn to make the LLM output a response that fits what we're trying to achieve. And then we feed that into the LLM and it makes a response. So this is the simplest like LLM system. Like in practice, if you want to just put an LLM in production, you could just have users write queries. You can put them in some of maybe your own custom prompt and use that, feed that into LLM and have it generate a response. And it's the pros of this type of system, the easiest type of system, is it couldn't be easier. The other thing is it works really, really good for almost no work, just an API call. You get the magic that is an LLM. The cons, like, why don't we do this? Why do we actually build something way more complex than just, passing things directly to the LLM? One is hallucinations. LLMs almost always try to give you a response. And they do generalize data pretty well, but they aren't necessarily backed by fact. So sometimes they will kind of guess something. Something will sound right. So they'll just hallucinate it. It's based on stale data. Like if you use ChatGPT, it was trained up to a certain year. And if you want to, for example, ask a question about a recent event, that's not possible. Similar, if you want to ask a question, if I'm a bank and I'm deploying an LLM, I can't use any of your data in this system, how it is. So I pretty much can undifferentiate a response. I can't use my context to give you a better answer. So one of the first things that people tend to learn when building LLM systems is fine-tuning. Fine-tuning is interesting because it's pretty analogous, I can't say that word, pretty similar to training in traditional machine learning. Well, fine-tuning, what we do is we take the LLM, we use a separate API that pretty much gives it a prompt and a response that we want it to have. So it kind of goes through and it trains. It pretty much tries to, it adds a layer, but more or less is changing its weights to try to get closer to the behavior that you desire. So again, it looks really similar to traditional machine learning model training. Fine-tuning is really simple. Depending on what model you use, it can be super easy. Like with ChatGPT, Revert with OpenAI, their LLM models all have APIs where you can essentially give it a CSV and it will just fine-tune off of that. And then it'll give you an outputted model that you can then use. So once you have that fine-tuned LLM, you feed it back into this normal LLM flow. So essentially, rather than using the base LLM, you use the fine-tuned LLM. The fine-tuned LLM will have context based on your data, and that will allow it to achieve better results. Sometimes this is called many-shot training or many-shot LLMs because you're so the first one was zero shot. I give it nothing, and then I just have it make a response. This is many-shot because I've given it some examples, so I'm kind of helping it a bit, giving it a little bit of training to be able to do a better job. The pros of fine-tuning. It's really similar to ML. It makes sense, like especially if you come from a data background. It's just a very just easy thing to understand. You can take advantage of pretty large data sets doing this because you can, it looks like training. And then 3 is this actually allows you to use human feedback. You can literally, some companies will hire people to curate the perfect data set to achieve the best fine-tuning. So it's a really good place to also be able to use human feedback. You can also fine-tune embedding models, but I'll come back to that actually. It's a little out of scope right now. The cons. It still hallucinates. LLMs always hallucinate. There's no way to just solve hallucinations. But the thing here that makes it maybe not as powerful as RAG, if you just fine tune, is it's kind of bad at memorization. Given the way it works, you're essentially you're taking a ton of data and you're generating a new layer of weights. It's going to generalize the data set that you give it. Now it's generalizing, which means it might not remember or pick out very specific details that you want it to remember. The other thing is because all of that data is being fed into the model itself, that means that all of the data is kind of compressed into the weights. So if you're using really private data, like people's personal conversations, with proper prompt injection, which means that a bad actor who writes a prompt a certain way can potentially pull that data back out. So essentially, the data that you put in via fine-tuning is always at risk of being pulled out via prompt injection. There are ways to mitigate this, but it's not solvable. There's no perfect way to avoid prompt injection. Finally, there is retrieval augmented generation. This is RAG. Now we're going to break down this really complicated looking thing, make it much simpler. But RAG is, let's break down what that means. Retrieval augmented generation. So generation is what LLMs do. They generate text. Retrieval augmented. So let's start with augmented generation. Augmented generation means that I'm still generating text, but I'm augmenting that in some way. I'm changing it in some way. And I'm changing it by retrieving relevant context. So you retrieve relevant context to augment the generation of LLM, RAG. Let me break it down in a way that's maybe a little bit easier to understand than that picture. So a user asks you, how should I be investing? You're a bank. They ask your chatbot, which is LLM powered. So, okay, based on that question, I can deduce some of the things I should grab. I might grab their age, how much money they have, average spending per month, spend categories, etc., and retrieve those analytical features. I may also retrieve paragraphs from maybe our customer service, like representatives, like if we have wealth managers and we have our conversations, I can retrieve relevant snippets from those conversations. So I pretty much pull together a packet of useful information, useful context to give to the LLM. Now, LLMs have one way to feed in data, prompts. So the only way to get this data into the LLM is to fit it into a prompt structure. So you might say something, for example, like given the user has these attributes and using content from our blog as context, answer this question. So I'm feeding the context into the prompt itself to achieve what I'm trying to achieve. This is RAG. The pros of RAG, it's much lower risk of hallucination. Again, there is no way to cure hallucination. But what you're doing is you're giving it the data that it should be using that is typically relevant to the question right there. So one, it's being fed into just a request. So it's safe from prompt injection because other requests would not get that data, one. Two, it's memorizes better because it's essentially reading that prompt. So it's reading that data as it's generating rather than having kind of generalized and memorized it before. It tends to achieve really high quality results. This is why RAG is becoming the standard of LLM systems in production. Cons of RAG, one is it's complicated. Like I showed you that picture, it's significantly more complex than fine-tuning and other things I mentioned. Two is you need enough context for this to be useful. If you can't generate a relevant or useful context, then it's essentially becomes a zero-shot issue. So if you're doing something like doing lookups, right? Like I mentioned, you're grabbing paragraphs from your wealth manager conversations. If you don't have that many, then you might not end up with pulling good information, and that might even result in your model doing worse than if you didn't do RAG. So you want to make sure that you kind of can cover your bases with context. Okay, so that's RAG. Let's break down a production. Let's break down the stages again. So the first stage is feature engineering and prompt construction. This is the stage where you take your data and make it usable by the LLM. This stage is almost synonymous with RAG. RAG is the process of taking your data and making it usable in an LLM system. Two, model experimentation and training. This is fine-tuning, which we talked about. One thing I want to make really clear is you don't have to pick RAG or fine-tuning. You can, and many people do, use both. You can do both together. Deployment, we'll talk about. And then the human feedback loops. So the point of the human feedback loop is one, it allows you to generate, you can use that to understand where things are going wrong Using that, you can begin to understand better features that you can build. So it's like, okay, features are just the context that you're giving. So you can look at the query and look at the prompt, and given that, you can be, okay, like I wish that we gave this LLM this context that we have. How can we get that data into the LLM when those questions are asked? And then two, the human feedback loop also feeds directly into fine tuning, because you can take the question, and then write your own response that you wish it gave, and then use that in the fine tuning step, which will hopefully help you achieve a better result. So these are the stages, and fine tuning and RAG both work together in a deployment grade LLM system. So let's break down the stages. Let's start with the data stage. So this is essentially the RAG stage. So I'm going to spend most of my time here today because this is mostly about RAG, or this specific webinar is mostly about RAG. So the data stage in LLMs is building prompt structures that achieve great results. So there's two parts to that. There's analytical features and text features or content features. Analytical features are things like, they're typically numerical. So they could be things like age, money in bank, average spending per month, spend categories. So someone asks, how should I be investing? You can have those analytical features. Coming up with those analytical features and deciding when to grab them is a really key problem. Sometimes you can pull this off by just coming up with the analytical features which you believe are relevant to pretty much every question and just feeding them into the model each time. Some people get way more interesting, and they actually will pick and choose which analytical features to use based on the prompt. But in general, what you do or how you do this is very similar to feature engineering. It is feature engineering. You take your raw data, that could be in like Snowflake, it could be in like iceberg tables. You build your features and you retrieve them via key value lookup. For content features, you find the relevant, like a good example is finding relevant paragraphs of conversations between the customer success reps and the customers themselves. So you will generate these or grab all the conversations or all the content-based data that is relevant potentially relevant to the problem at hand. So like if it's a customer success or service bot, then you should probably take all of the conversations between humans and other humans, I guess, and use that to help the model do a good job. You can also use that for fine tuning. But for the RAG perspective, you would chunk that data into the right size pieces. So LLMs have context windows. Some different LLMs have different sizes. In practice, after like the larger the context window, the less likely the LLM is to use all of the context. And in general, there's a hard limit of how big it gets. So you want to make sure that you feed the right amount of data. You don't want to overfeed in data where it starts to maybe pay attention to things that aren't relevant or ignores the pieces that are relevant. So you want to chunk the data into the right size pieces. Now, the right size pieces is going to be completely dependent on your use case and the data. So there is no like perfect way to do it. It could be per sentence, it could be per paragraph, it could be some other thing. Maybe different chunks have different sizes based on something. The best way to do this is via evaluation. Like this is why, like when you put things in production, you want and need to have evaluation set up so that you can make these things better over time. Once you have these conversations and these paragraphs and chunks of text, you want to store them in a search engine. Now, to some people, that might come off as confusing because we talked about vector databases. In practice, doing an embedding lookup on a vector database is just a type of search engine. It is a way to search for relevant content based on the query. So let's break down RAG a bit. So this is that really complicated image I showed when I showed you RAG. Let's talk about, so there's two pieces. There's the piece that happens in the background, which generates your data or generates like fills your vector database in your inference store. And then there's the per request. So let's talk about what happens in every request. It starts at the right and goes up. So it's a circle. So you start with the user has a question, a query. You might pre-process that query. So you might break it up or do something with it to make it maybe the core components of the query, or you can use it for other reasons. Once you have that query, you embed it. You embed it using an embedding model. You can think of it as an embedding model generates a search key based on that query. I mean, in practice, an embedding is a vector representation of sparse data like text, and it's used for similarity search. But you don't really need to even think about all that in most cases. Really, all you need to think about is I have a query and I turn it into like a search key, which is the embedding. I use that search key on my vector database to retrieve relevant context. I also grab, for example, like the user ID and other IDs to do key value lookups on the inference store to retrieve relevant features. So like their age, their money, the analytical features we talked about. You can grab those as well. So then you have relevant text and relevant features. This is your context. Once you have that context, you feed it into your prompt. So that's how you, again, the only way to get data into an LLM is via prompt. So you have to put it in prompt form, and then you feed it to the LLM. And then the LLM gives you a response, and that response goes to the user. So how about the vector database and the inference store? Like, how do I get my data in it? Let's start with the vector database first. The interesting thing about the vector database is it's like the same thing you did with the query. So you'll take your documents, you'll pre-process them. Like I said, that could be cleaning them up. It could be chunking them. It's essentially building these like snippets or these chunks of relevant context, the smallest amount of relevant context chunk. So if it's too small, then it's not useful enough context. It's like a cutoff paragraph. If it's too big, then there's too much stuff that's like superfluous and it can confuse the model. So you want to find the right size, which again is going to be super dependent on your problem and use case. Okay, so once you have that processed text, you use that embedding model again. The same embedding model has to be the same embedding model that you're going to use in the other side, the request side. And you generate embeddings from them. Again, the embedding is like a search key. Then you store the text and the search key together into the vector database. That makes all of that processed text searchable via embeddings. With analytical features, very similar to like how things work in tabular data. Maybe you have queries or transformations that eventually generate your features, and you store those features into some cache to do lookups on, like Redis or something, or Dynamo. So together, you are taking your data, you are putting it and processing it into a form that is usable per request. In each request, a user asks a question and you retrieve relevant context to that question to generate a response. That is RAG. Let's dive a bit into embeddings. So I mentioned embeddings are kind of like that search key. So embeddings are a vector representation of sparse data. It could be images, it could be a lot of things. So people are often confused when I say like text and images are sparse data. Let's start with images. So I think images are easier to understand. So when we look at an image, right, in our head, like these are types of clothing. When you look at a pair of jeans, your brain automatically looks at it and says, yeah, that's a pair of jeans. But if you think about it, like from an image perspective, all of those pixels, each of those pixels are being used to just get across this more abstract representation of this is a pair of jeans and they're blue. So an embedding is like the same, it's kind of like what your brain does, where it takes this sparse data, which is like your field of view, and it turns it into like that representation of what that means. That's what embedding is. Embeddings have this interesting property in that embeddings or things that are similar are close together. They're like embeddings are literally vectors, so they are like points in space. They're typically high dimensional, but in theory, like you could create a three. I'm not in theory. You can create a 3D embedding. So an embedding that has three vectors. The reason we use multiple dimensions is it gives the model more room and space to be able to like properly cluster things. But if you just want to visualize it, you can put it into 3 dimensions. And if you put it in 3 dimensions, you can see that these things will be close together. Someone asked a tensor. Yeah, a tensor is just a more generic. Yeah, a tensor is so it's specifically a 1D tensor. So an embedding is which is a vector. So a tensor can be like a 2D tensor is a matrix. You can have 3D tensor, 4D tensors, like that's just how many axes there are. But with an embedding, there's just one axis. So it's a vector, which is a vector is a subset or a vector is a subset of tensors. But yeah, so it's literally just like you take a piece of text and you turn it into an embedding, which is like, 1.2, negative 3.8, like it just looks like random numbers to you. Someone asked which methods for embeddings are being used. Not sure I understand, but I think I'll try to answer the question. So to build an embedding, you need a special type of model. It's called an encoder model. There are many examples. I'll actually get into that in a moment, but you generate them using models. How do we use them? We can use them in 2 forms. One is just to use them for nearest neighbor lookup. So it's like, I want to find similar things. So then I do a lookup based on that. And then the other way of doing this is actually using the embedding itself as a representation to feed into a model. This is super common with like recommender systems, where I will actually use an embedding and feed it into a traditional model. This is why embeddings actually far predate LLMs, because this is how we used to use them. So retrieval via vector database. A vector database, what it is it has a special index that makes it really fast to be able to do a nearest neighbor lookup. Because with an embedding, how to explain it? With an embedding, if you were to have to do a nearest neighbor lookup, like a real nearest neighbor lookup, it's very expensive. You technically have to check everything. Now, you can approximate nearest neighbor and achieve really good results in a way faster time. So that's what vector databases do. They are a way of doing like an approximate nearest neighbor lookup. So how do we create these embeddings? So we use something called transformers as the not the Autobot in the middle, but it's a type of model. It looks like the thing on the left. Again, you'll maybe realize that transformers also have something to do with LLMs. So there are encoders, decoder, encoder, decoder. LLMs are decoder only models. Embedding models are encoder only models. So it's they're very related. Like the research that became LLMs was originally the research that was creating embeddings. One of the most common and the first like things that put LLM or put embeddings on the map, and also some would say is like the grandfather of LLMs, is a model called BERT. So we use models to generate embeddings. Now, I have a little aside here to mention that this is pretty complicated. There's a lot going on here. I really recommend a data orchestrator. This is a problem that we had is we needed something to orchestrate all this. We needed an orchestrator that was kind of aware of RAG, understood embeddings, understood analytical features, did all this stuff together. And that's actually why Featureform exists. So Featureform is an open source product. It works as an orchestrator and metadata store. It sits above your vector database, your transformation layers, your embedding models, and allows your engineers to be able to build these RAG pipelines in a way that is much easier. It makes it so that things are organized. So you don't have all these random variables. You don't have random tables in your vector database. You don't have like these kind of crazy jobs that copy and paste things. And it creates automatic documentation. If you start dealing with RAG at a large scale and like a production pipeline, you will quickly find that a lot of problems around scale start to come into play. And you start to realize that all of these things that we've learned how to do before, like data orchestration, et cetera, become really relevant. But the tools like Airflow are too generic. They don't understand embeddings. They don't know how to work with embeddings. So things like Featureform exist to cross that gap. Okay, I want to come back to the next stage. That was RAG. That was the data piece. That was the core bit of RAG, and where again, I said we spent most of our time today. I want to talk a bit about fine tuning, which is the second stage. Well, fine tuning, we generate a set of good, question answer pairs. So like prompt answer pairs. We use the fine tuning APIs to tune both our models for generation. Now, you can, like I showed you before, you can fine tune the model itself. For RAG, you can actually fine tune your embedding model too. When you fine tune an embedding model, so an embedding models, they generate embeddings, obviously, they tend to kind of cluster things, but they are generic. They try to cluster the best they can. For example, you might have clothing. And the clothing is, there's different types of clothes. There are jeans, shoes, and shirts. And then there's also very different colors. They're either red, green, and blue. So the embedding model might tend to focus on the colors and cluster by red, green, and blue. But you actually wanted to cluster based on the type of clothing. So using fine tuning, you can have the embedding generate the clustering you want, which will again allow you to have RAG do a better job. You need to then store and version these models. That's like one piece that we don't talk a lot about. Like in practice, you end up fine-tuning a lot of models. You end up iterating on these things. Storing, managing, dealing with all that is a huge problem to solve. Next is deployment. Deployment could be as simple as just using an API. There are also vendors that have kind of like the open source models in like GPT form or ChatGPT form, which you can use. I keep using ChatGPT and OpenAI interchangeably, but you get what I mean. You can also roll your own. So you can use frameworks like Seldon or Bento, which allow you to deploy your own model on your own hardware. So using APIs is great when they're really, really easy. The problem with APIs is you do not own the hardware and you do not own, unless you pay them a lot of money, there's no SLA. So as we've all seen, ChatGPT sometimes is really slow, or it goes down, or it does whatever. If you want to be able to control your own performance guarantees, you would have to manage and deploy your own hardware. But then you have to deal with that complexity. So there's a trade-off depending on what you're trying to do and how important and critical it is for your use case. Finally, there's monitoring and evaluation. This is the key to a production LLM system. You need to track the conversation. You need to track the requests. You need to track the responses. You need to build systems to catch when the model is misbehaving. Those systems can be paying someone to go through every conversation and finding bad examples. That system could be that users like kind of give a thumbs up or thumbs down, and then you use that information. The systems can also be implicit. What that means is you can find that if the user is trying to ask the same question over and over again, that might mean that the answer is not great. There are lots of ways, and this is where you can get really creative on how to get feedback from the behavior. And then you use that feedback to generate data sets. These data sets can be used both for fine tuning. So you can get request response pairs that are bad, edit the response to make them good, and then feed that back in for fine tuning. You can also use those to fine tune RAG, or sorry, to change like your RAG system. Maybe you look at that and you're like, huh, this maybe the context it got via RAG was not great. Or maybe you wish you had given it more context. So you can use this to change the system to achieve better results. But you need to track this stuff. You need to know what's happening in production. This is also a place where you can come up with like guardrails. You can build like hard-coded or more hard-coded like stops so that it doesn't misbehave if you need it to. Yeah, feedback is key. RAG can get much more complex. There's advanced things you can do. For example, there's re-ranking. Re-ranking is when you do the embedding lookup, like that vector database lookup. You look up, let's say, 100 things, but then you actually use a second model, like a normal traditional machine learning model, to decide out of those 100 things, what are the 10 that we think are best for this specific query. There's also model-based retrieval, where you actually use a model to decide what context to grab. You can use model-generated features. So you can even use models to maybe properly cut up your context. You can use model to generate things like credit score, which can be fed into your model. So you're actually using traditional machine learning models alongside LLMs. There's agents. Agents is where you're doing kind of the same thing, but you're using LLMs to feed into other LLMs. So you kind of start to build this chain of requests and responses. And then you can also use different. So for example, like if you're an e-commerce company, you can even do things like generate embeddings based on images. You can use images, text, or text obviously, but you can use images, audio, video, to also achieve different results and to achieve a better RAG system. These things are kind of out of scope. A lot of these things are very experimental. Like people are just starting to try these things out, and I've never seen most of these things in production. The only thing I've seen is agents. I haven't seen any of the other things as of today, and multimodal, but I haven't really seen a lot of re-ranking and model-generated features. But I'm sharing this more because people will start figuring this stuff out and writing about them. So I wanted to give you all kind of a sneak peek on what's the cutting edge right now. And this also kind of shows that GPT is another tool in our tool belt. It is a very powerful tool, but it is not the only tool. The things that we learned from traditional machine learning and data science can come into play, can feed in and allow you to build better systems. A lot of times when new technologies come out, people start to focus on what's different. But to be successful, it's remembering what's the same and what can we leverage that we already have, and what learnings from like traditional machine learning and data science can we leverage to build the best LLM system possible. Similarly, also sometimes just knowing that maybe an LLM is not the right tool for the job, like for things like fraud. It's really nice or easy when you have a shiny new tool to try to apply it to everything, even when it's clearly not the right tool for the job. For example, when deep learning came out, everyone was trying to turn all of our models into deep learning models. But we realized pretty quickly that some of our old models actually performed better than deep learning. The same thing I'm seeing here too, where people are actually trying LLMs for certain use cases where they actually do worse, and then people revert back. LLMs work great in chat-based and text-based environments. Outside of that, they don't tend to do quite as well. So with like more traditional tabular data, data science focused things, they have their uses and there are places where they really shine. But also just remembering that this is another tool in your tool belt, and using these tools all together is what's going to allow you to build the best and most robust system. So that's all I have for today. Thanks for, I'm sure there's a lot of information. Thank you for listening. If there's any more questions, or for any questions that maybe I didn't properly answer, feel free to throw them in the Q&A. Then Marie, you can maybe let me know if there's anything on LinkedIn or Slack, or sorry, rather Twitter, that I missed.
Will do.
Awesome. I'll give it one moment to see if anyone has any questions. Maybe Marie, in the meantime, I will make you host again so that you can kind of say our sign off.
Sounds good. Yeah, thank you guys again for joining this webinar. After this, I'll send you guys an email follow-up with the recording of this webinar. I'll also send you links to our Slack community and our docs. Yeah, that's pretty much it. Anything else, Simba?
No, that's all. If you have any questions, and you didn't get to them or you're thinking of them later, you can ask in the Slack community. That's the best way. You can also always email me if you want to do it privately. I'm just simba@featureform.com. Awesome. Thank you all.
Have a good one.